Hello everyone, welcome again to this video. So in this video we are going to talk about the moment generating function in general and for exponential distribution. So the moment generating function, as you can see, it's a function with a parameter, and what it does, it is generates functions. So firstly, what does the term generating function means? Now a generating function generally looks like this. So here capital F can be called as a generating function for f of n. This is because if you expand the series, you will see that the first term is f of 0 into k to the power 0. The second term is f of 1 into k to the power 1. Third term is, and so on. So it basically means that the function f of k, when expanded as an infinite series, shall give you different values of f, basically all possible values of f, and they are contained as form of different coefficients of k. So the coefficient k to the power n, the coefficient of k to the power n basically gives you the function f of n, right? That is why capital F is called the generating function. Now moment generating function, on the other hand, would be something like this. So let me just write down the statement and the theory, and then I'll explain. So this is the definition for the moment generating function, where mx of t, this is the moment generating function where t is a parameter or a variable here, and it is given by expectation of e to the power tx, where x is the random variable, okay, where x is the random variable which follows the PDF fxx, okay. So this is basically the definition, but we need to understand how to find it and how do we actually evaluate it. So different things that can be derived from the moment generating function are as follows. Firstly, e of e to the power tx is basically this function, right? So expectation of anything, as you know, is just that function multiplied by the PDF of the random variable, and we have to integrate over the real line. So e to the power tx fxx dx, integration over all the real line will give you the expectation for e to the power tx, and also this means that mx of t is equal to this integral, right? Now what we can do is we can use this to understand why it is exactly called the moment generating function and not something else. So recall the Taylor series of x, which is as follows. So this can be written in summation notation as right, and as we know this converges for all x, so it basically converges for all x. Now if you replace x by tx, you get so this is what you get, right? Now if we use this representation of e to the power tx inside the integral representation of the moment generating function, we get now what we can do is we can integrate this integral and this summation, that is we can take the summation out and we can put the integral in. This is valid due to Fubini's theorem, also due to the dominated convergence theorem, and this is valid because you see that this series converges. This PDF is like always positive and all the terms in here are positive, right? So what happens is we can do that in case when a series actually converges, and it does converge in this case, or so we assume that. So in that case we have n equals to 0 to infinity integration over the real line t to the power n x to the power n by n factorial into fxx dx. Now we can take the constants which are not inside the integral outside, so we can write it as and now as you see this thing exactly here is basically e of x to the power n for the variable x, right? So we can write this as right. So what we got is the moment generating function is given as since e of x to the power n is integral over x to the power n fxx dx, therefore mxt is equals to an infinite series n equals to 0 to infinity t to the power n by n factorial into expectation of x to the power n. So we see how the moment generating function basically generates the moments one by one. So what this means is this: the first term would be t to the power 0 by 0 factorial into e of x to the power 0 plus t to the power 1 by 1 factorial into e of x to the power 1 plus t square by 2 factorial into e of x to the power 2, and so on. This is what we call an exponential generating function. And to recover any moment, what we can do is we can differentiate the moment generating function n times, because then when you differentiate n times, all the coefficients of t which are less than n will vanish and the nth coefficient will remain, and it will only give you e of x to the power n. So this is how it works. So this is why the moment generating function can directly give you moments on its differentiation, and that is why we would like to evaluate moment generating function for all of our distributions which we are going to study from now on, right? Okay, so from the next lecture we shall do that for the exponential distribution and for the distributions that we study. So for each distribution that we study, we are going to find its PDF, its CDF, its mean, which is the expectation of x, second moment, variance, standard deviation, and moment generating function. Once we complete everything, we would be looking at solved examples to conclude the chapter for one variable continuous random variables. Right, so I guess this is it for this video. Thank you for watching. So please download the Breatter Maths app, which is given in the description. It is a mathematical app where you can find all the necessary statistical calculators like chi-square calculator, one variable means, population means, t-value, and much more. You can also find calculus related calculators like integration, derivatives. There is a section where you can find what's coming up next. There is a section completely devoted on mathematical notes where you can find notes on probability, statistics, calculus, and many more are there to come. In those notes we have already explained all the examples, all the problems and theory, and we are just covering the video lessons and solutions of those here. You can check that out. Also, you can see the video solutions in a separate section where you can understand and give a feedback on what to expect next. You can ask for a problem, you can ask for a theory section as well. So please do check it out, and also do subscribe to Breatter Maths app and also its YouTube channel.